If you track the story of humanity, you see this one consistent thread, right?
Hmm.
It's how we keep changing the tools we use, the tools for defense and the tools for, well, for fighting.
Exactly. We started with simple things. Wood, hide, just muscle.
And now we're dealing with what? Networked robots, satellites up in space. It's been a huge, centuries-long journey.
It really has. And that's what we want to break down here. We're going to look at these big technological shifts in weapons and protection.
And not just what was invented, but why it mattered. Why each new thing completely shattered the old rules.
Right. We're going to move from the sheer physical weight of defense to the pure speed of computers.
Okay, let's start at the beginning then. The age of physical defense. Before we got good with metal, the most important thing for a soldier was the shield.
Absolutely.
Mhm.
The earliest defenses were all for close quarters combat. It's about spears, clubs, that kind of thing.
So the shields had to be simple.
Very simple. Early on, they were just wood, maybe layered, or tough animal hides stretched over a frame.
They had to be light enough to carry around all day, I imagine.
For hours, yeah.
Yeah.
But still strong enough to take a few hits without just, shattering.
That balanced protection versus portability, that must have basically defined how people fought.
It did. And you see different cultures solving that problem in different ways.
Like the Romans, right? With
Yeah.
that big rectangular shield, the
The-
scutum.
The scutum, yeah. That wasn't just a piece of armor. It was the core of their whole fighting system.
How so?
The shape let soldiers lock them together. They could create that famous testudo, the tortoise formation.
Ah, right, a walking wall.
Essentially, yeah.
Yeah.
A nearly impenetrable wall of wood and leather against arrows or a charge.
But the flip side must have been huge if that shield breaks.
You're done. You go from being part of a machine to just being completely vulnerable.
So what happens when the weapons get better than just simple clubs and spears?
That's when protection had to get better, too. It had to become total. And that's where medieval armor comes in.
The next great leap forward.
Mm-hmm. As weapons like long swords and battle axes got more refined, defense had to shift from just one spot to covering the whole body.
The first step was chainmail, I believe.
Chainmail, exactly. Thousands of tiny, interlocking steel rings woven together.
That must have taken an incredible amount of time to make.
An incredible amount of skill and time. But it gave you amazing defense against slashing blows.
But the real peak of all this was plate armor, the full steel suit.
That was the ultimate physical defense. Worn by wealthy knights, it covered them from head to toe.
Now, we always think of those knights as being really slow and clumsy. Is that fair?
It is, sort of, but you have to think about the trade-off.
Okay.
A full suit weighed maybe 50 pounds, which sounds like a lot, but it's about what a modern soldier carries today, just distributed differently.
And it was hard to get into, I'd imagine.
It could take an hour, and you'd often need help from a squire. But more importantly, it changed the economics of war. Only the rich could afford it.
So it reinforces the whole class system.
It solidifies the knight as the top dog on the battlefield. He was pretty much immune to what a common soldier could throw at him. It was the best personal defense system you could get.
So if plate armor was the ultimate defense, what made it suddenly obsolete?
Gunpowder.
That brings us straight to the gunpowder revolution.
The introduction of gunpowder, which came from China, didn't just add a new weapon to the mix.
No.
It reset all the rules. Everywhere.
Explain that. How does a bit of powder make a super expensive suit of steel useless?
It's all about force. The sheer kinetic energy from a lead ball fired from an early gun could just punch right through traditional steel armor.
All that metallurgical advancement, gone.
On overnight. Suddenly, that highly trained knight in his custom plate armor was no safer than a peasant who was just handed a gun.
So the focus shifts from thick metal to...
The speed and distance. And the power dynamic shifts from the individual's defense to the group's firepower.
And by the 18th century, the musket is the king of the battlefield.
It really was. These long, smooth-bore weapons became the standard. And they led to a really interesting tactical shift.
Because they weren't very accurate, were they?
Not at all. They used a flintlock mechanism, and firing just one musket was basically luck.
So if they're not accurate, how did anyone win a battle with them?
By trading accuracy for volume, for discipline. The tactic was called volley fire.
Right, the long lines of soldiers.
Exactly. Armies would line up shoulder to shoulder, maybe 3 rows deep, and they'd all fire at once on command.
A wall of lead.
That's what it was. It was designed to just overwhelm the enemy. And even though they were slow to reload, a good soldier could maybe get 3 shots a minute. The psychological effect was immense. The smoke, the
And
noise.
if the enemy got too close before you could reload,
The musket had one last trick. The bayonet.
you just turn your gun back into a spear.
Basically, yeah. A knife or a spike you fix to the end. It shows that even with new tech, you still had to be ready for old-school close-up fighting. It was all about discipline.
That discipline was everything. But then technology starts focusing on making individual weapons better, more range, more precision.
And that's where we have to talk about the kings of battle. Our
Sure.
cannons. Cannons, right? They'd been around for a long time, firing stone or metal balls to knock down walls.
But what changed to make them a long-range threat?
It was about understanding trajectory and explosive power. Cannons got bigger, stronger. They could fire high explosive shells that weighed hundreds of pounds for miles.
And this introduced the idea of indirect fire.
Meaning you don't even have to see your target.
Right.
The crew had to do the math. Calculate the angle, the elevation, factor in wind, using mathematics to predict where that shell would land.
That's a huge conceptual leap.
It is. It's the ancestor of every long-range missile system we have today.
So while the big guns were getting longer range, the individual soldier's rifle was getting way more precise.
All thanks to the Industrial Revolution in the 19th century. And it comes down to a really simple change inside the barrel called rifling.
So what is rifling? What does it actually do?
It's just spiral grooves. They cut these grooves on the inside of the gun barrel, and when the bullet is fired, those grooves make it spin really, really fast.
Like throwing a football with a spiral.
Exactly like that. The spin stabilizes it, it reduces wobble, it reduces drag, and lets the bullet fly much straighter and much farther.
So suddenly the average soldier could actually hit a person from hundreds of yards away.
Precisely. And that was the end of those line formations. Standing shoulder to shoulder just became suicide.
Troops had to start using cover, spreading out.
A whole new kind of tactical thinking was needed. The rifle completely changed infantry combat.
And that new precision then sets the stage for, well, for the horrors of the 20th century. The rise of automatic and mobile warfare.
And the symbol of that era is the machine gun.
It just changed the whole equation.
It changed everything. It favored defense overwhelmingly. Suddenly, a small crew could have the firepower of an entire company of musketeers,
Firing hundreds of bullets a minute.
without needing to constantly reload. The Gatling gun was an early version, but later on they became much more portable.
And the strategic result was just paralyzing.
Devastating. Any kind of charge across an open field became impossible. You'd just be mowed down.
Which forced armies to dig in. Literally.
Right. They dug deep, fortified trenches for cover. And that led to the famous bloody stalemate of trench warfare in World War I.
So if the machine gun created that stalemate, a new machine was invented to break it.
A tank.
A mobile fortress.
It was a direct response to trench warfare. It combined three key things. Thick armor, powerful weapons, and this is the crucial part, tracks for mobility.
So it could cross trenches, crush barbed wire.
Exactly. But those first tanks were clumsy. They weren't an instant fix.
It broke down a lot, right?
All the time. They were slow, they got stuck in the mud, and the conditions inside for the crew were just awful. But they were immune to small arms fire.
And the psychological impact must have been huge.
Immense. They proved the concept. You had to bring mobility and heavy armor back together to beat static defenses.
And today's tanks are a world away from those early ones.
Completely. They're fast, they have advanced targeting computers, composite armor, but the core idea is the same. A protected mobile weapon that can dominate ground combat.
Okay, now we have to pivot completely. So far, war has been a two-dimensional game, land and sea.
But the 20th century adds two new domains, the sky and the deep ocean.
Let's start with the sky. Combat in the air.
Airplanes really added a vertical dimension to war. At first, they were just used for scouting. Pilots would literally drop small bombs by hand.
Or shoot each other with pistols.
Yeah, that happened. But it all changed when engineers figured out how to mount a machine gun that could fire through the propeller.
That's when dogfighting became a thing.
That's when planes became deadly, and the race was on. The next huge leap was the jet engine.
Which let planes fly faster than the speed of sound.
A barrier no propeller plane could ever cross. Today's fighter jets are basically flying computers. They carry smart missiles that can lock onto a target miles away.
So control of the sky is no longer a nice to have.
It's essential. It's often the first thing you need for any successful modern military operation.
And while all that was happening up in the air, warfare was also going deep underwater.
With the submarine, the ultimate weapon of stealth.
Its whole purpose is to stay hidden.
And attack surface ships with torpedoes. The early subs were Well, they were incredibly dangerous for their own crews. Cramped, running on batteries that needed constant recharging.
So what allowed them to become these global strategic weapons?
Nuclear power. Nuclear propulsion changed everything.
How so?
A nuclear-powered sub can make its own oxygen, its own electricity. It can stay submerged and travel the globe for months without ever surfacing.
And they're almost impossible to find.
Incredibly difficult.
Yeah.
They shifted naval power away from big, visible battleships to the quiet, hidden threat of a single submarine.
Which brings us to our final section, the digital era, smart weapons.
Yeah, and this is where we move away from the physics of wood and steel and into the world of pure information.
It's all about computers and satellites.
It's about how all these systems, satellites, computer sensors work together. They've turned dumb bombs into, well, into surgical tools.
We're talking about precision-guided munitions, PGMs.
Right. And they work because they have better information. Instead of just math, they use GPS signals from satellites or lasers from the ground to actively guide themselves to the target.
We're talking about a missile that can fly hundreds of miles and hit a specific window.
That's the level of accuracy we're talking about. It's a massive leap from an old cannonball.
And what's the strategic advantage there?
It's efficiency. You need fewer weapons to do the same job. It saves resources, it can reduce collateral damage, targeting becomes much more surgical.
And this all relies on that constant flow of digital information from satellites.
The satellites are the eyes, they track movements, they find targets, they guide the weapons.
And the newest chapter in all of this is, of course, the drone, the unmanned aerial vehicle.
Yeah, and the key innovation there is that it completely decouples the pilot from the danger.
The person flying it is safe, thousands of miles away.
Exactly. Drones are cheap, they can stay in the air for a long time, and they're incredibly effective for scouting and for targeted strikes.
And this isn't just about remote control anymore. We're moving towards autonomy.
We are. Robotics are already used on the ground to handle really dangerous jobs, like disabling bombs.
But the next step is AI.
True autonomous systems. We're developing artificial intelligence that doesn't just guide a weapon. It could help the machine interpret data and potentially make targeting decisions on its own.
That's a huge leap, taking the human out of the decision loop.
It is. And this move toward AI-driven warfare, it's the next great frontier. It's all about who has the better information and who can make decisions faster.
So when you look back at the whole arc, from a Roman shield to a satellite-guided missile, it's just a profound journey. We've gone from a soldier relying on the strength of his arm and the thickness of a piece of wood
To relying almost entirely on information, on algorithms and computer processing power.
The interesting thing is that the next great defense seems to be born right alongside the next great weapon.
It's a constant race. And today's defense is about controlling data, not just blocking a physical object.
Which leaves you with a pretty big question. If the history of war shows that every defense eventually fails, what kind of system could ever defend against an enemy that isn't powered by force, but by a faster algorithm?
Something to think about.
See you next time.